Welcome. We're going to run through the milling tutorial from the main Powerstation manual. It's on page 21. Also, you can download a copy of the tutorial from our website. Step 1. Step 1 is just starting Powerstation. Hopefully at this point you know how to do that. Alright. Step number 2, we're going to start by drawing a box that kind of contains the overall shape of the part. So we're going to say geometry. We're going to say shapes. And we're going to say box. It's set. Well, we're going to enter the coordinates of where we want this to start. We're going to have the width of 5 inches. We're going to do the height at 4 inches, which it already is. And that's it. Sharp corners. Okay, so there's our box to start with. For step 4, we're just zooming in, display, and we say zoom extents, just to pull that in as big as it can be on the display screen. So the first thing we did in the tutorial here is to change this line up here. It explains that we're not going to need this whole line, and there's many ways to do this, to leave it there and trim it later. In this case, it just seemed a lot easier to say, okay, modify, trimming, change the line end, take the end of this line, and I want to change it to a point. In this case, I'm going to do distance from an end. I'm going to say on this line, and it's just a 1/2 inch from that end. Again, there are many ways to accomplish that. We could have also just defined a point that was a 1/2 inch from the end. But let's continue on. Now we have step number 6 from the manual. For step number 6, we're going to put in the geometry, arc, and the coordinates. We're actually going to give hard coordinates for this one. 1.25. The y coordinate is 3 inches high. The z is 0. The arc radius, I'm going to use the math in the system. 1 plus 3/8. Starting angle is 0 of the line, end angle is 360. Cool. Now we have our arc up there. Let's display. We can also do it up here. We can hit this. This will fit it back on the display again. Draw a tangent line on this arc. This will be the line that goes over here on. So we're going to say geometry, line, and we're going to say tangent to 1. There's the arc, and the angle is 45 degrees. As you can see, I accidentally drew it on the wrong side. We wanted that line on the other side of this arc. So we just say undo, undo. We can do the same command again, geometry, line, and just say tangent to 1. We'll say it again, and this time we'll say minus 45 degrees. Now we have the line that we're looking for. On to step number 8. Okay, now we're going to draw a line, this line that forms part of that V shape that we have there. Alright, I'm going to select it from this menu here, from the line, from the geometry toolbar here, just to do something a little different. I'm going to say, okay, I want to make a line tangent to 1. Alright, again, a lot of ways to do this. I'm going to select this. If you hit the escape, see it says select a point or arc or escape for a point menu. So you can press escape and say take the end of this and do it at 45 degrees. Okay. Now just to show you one of the nice new options that we have, let's get rid of that and do it again. We can turn on our power snap option and say we want to do things by cursor. So we can just say tangent to 1. Okay, we've got it back again. Next thing we're going to do is we're going to add a fillet in here. The idea of using the fillet is to both trim these lines up and put that fillet radius inside here. I can steal that in the arc or the trimming menu. I'll say arc, and I want to fillet. I want to fillet this and this. The radius was 0.5. Okay, that cleans that up. Next, we're going to go about trimming up the part, cleaning this up so that it looks more like the part that we're trying to make. We're going to come over here and say easy trim and start getting rid of things we don't like. Let's get rid of this one. We don't need that, and we don't need that. And lastly, we don't need this or that. Alright, you can press escape when we're finished. And I'll do the zoom extents again. So now it's starting to look like our part. The last part of drawing up the part, we're going to draw the actual, we're going to draw some circles to represent where those holes are going to be drilled. This is purely optional. You do not have to, in the case of a simple grid, a simple line of holes like this, you can just drill them, you can just define them as you drill them. You don't need to generate them ahead of time like this. But for this case, we're going to do it. Pattern, we just have a linear pattern. We say, what do we want to do? Holes, or points. We want to do holes. The radius is 1/8 of an inch. So now we say, where's the first hole? So we're going to select coordinates and enter in the coordinates of the holes, 1 and 1 of the starting hole. All right. Now we have a simple linear patterns here, so we say we got 4 holes. The distance between the holes is 1 inch. The base angle of the holes, the rotation angle of them, is 0. So now it drew in the rest of the holes for us. Again, purely optional. This would be a good time to save the file. Let's save it, and let's call it Video Lesson 1. Next thing we're going to do, we're going to begin the machining on this. So for the machining, everything starts with the operations, from working from an operation list. So we say machining, and we say the operations manager. Okay. Now we fill in the operation manager. What are we going to fill it in with? We're going to say the first thing we have is operation 10. Let's make it make the toolpath for it a nice red, because it's roughing, and we'll just say put in some description, and let's give the details of the tool. It's Op 10. It's a milling operation. It's tool number 1. Offset number. Tool diameter is going to be a 3/4 inch. Stock allowance, we'll leave 20 thousandths on everything. Inches per minute. And a speed, again, I'm just pulling numbers out of the air, 1200 RPM. Okay, that's all we really need to do for each tool. Okay, so here we're finished filling in the operations that we want to use. That brings us up to step 14 in the tutorial. Step 14 just offers to print the operations out. It makes a nice little printout showing you the tool numbers and the speeds and feeds for them and such. Step number 15. We speak in the demo about it's a good idea to put your machining on a different layer. It's not mandatory at all. You can leave it all on one layer. Layers just help you better sort things out. So what we're going to do is simply go up here to the layer, click on it, and say, okay, let's just make a new layer here, or take layer number 1 actually, and we'll call it machining, and we will make it the current layer. That way all the machining is on its own layer, and it will be very easy to, if for any reason we wanted to just see the machining and not see the geometry, or vice versa, makes it easy to do. I reloaded the operations menu. I could have done this before, but I reloaded the operations menu, and I'm just going to select which operation I want to use. I want to use the roughing operation. Okay, so now I'm going to make the first rough pass around here. We can do that with a chain cut command, which chains profiles. We can either get it here with the on the machining bar, or we can go to the machining menu and say we want to do chain cutting. Okay, in chain cutting, you click where you want the tool to start. What it's basically going to do is going to move away from you. So if you start at this end of the line, it's going to move upward. If you started at this end of the line, it's going to move downward. That's how you control your climb versus conventional mill. So I'm going to start from here. Escape for none. I want to chain the whole part. If you only wanted to chain half of it, you could click which line or arc you wanted to stop before. Press escape. It chained the whole thing. Confirms that you like the chain. And then finally you select the side of the tool, that line to put the tool on. I want the tool over on this line side. X and Y cutting feed, a Z cutting feed, the Z clearance plane that we're going to use for rapids over the part and up and out of the part, the total depth in Z. Okay, and then we have a few other options here that are good. We have the rapid to start position, G4142 cutter compensation, probably want that. Custom approach into part, we'll get to that in a minute. Retract Z when we're done, so when you're all done going around, bring Z back up to this Z clearance plane. And corner rolling, which basically you will see it in action. It creates, anytime you have a sharp corner, it creates a tool path that rolls the tool around the corner. It doesn't actually cut an arc, it just pivots the tool around the corner. Makes a faster tool path, cuts down on burrs. It's kind of a nice option. The custom approach into part is the next thing we really have to look at. First of all, you cannot have cutter comp without defining a custom approach into part. So even if you turn these on, but you don't bother to define an approach into part, you won't get your cutter comp. Let's select an approach. And let's just start from the basics. I'm taking just a simple linear type approach to it. I'm going to say a 1/2 inch long at 45 degrees. Now that makes 45 degrees from the surface from the line, from the entity that you selected. A lot of times that can be a little confusing in the beginning. I'm going to leave them both at 45 and show you what I do. If for any reason you're confused about these angles, don't worry about it. Put in an angle like that. And let's say go. Good. Okay. So that looks pretty good. Let's bring it all back on the screen again. So we came in at an angle, went around, came out at an angle. Okay. Well, all I was driving at is, and you'll see this later on, is that if there's any problem with those angles, you can simply go back, click on the angle, change it, and say regenerate the tool path. Okay. All right. Next thing we're going to do is take the finish pass. Finish. We're going to do again a chain cut. Basically the same thing as the last one. Start here. I'm done. Escape out of there. These chained okay, yes. Cut on this side, and now we have the same basic thing. The difference will be the tool size. So let's say okay, and now it generates a finish path around there. Next thing, we basically jumped ahead here. We're up to about, what, step 19, step 20. Okay, step 20, we're going to drill those holes. Let's go back again to the operations, select the operation that we want to use, and we're going to do some drilling, machining, drilling, and linear. Same basic thing as what we had down there. Number of holes, 4 holes, inch between them at 0 degrees. Okay. Now instead of entering in the coordinates, we can just say take the center of this hole here. And now we have the drill specification. You can say the type of cycle up here, deep drilling, standard drilling, tapping. You can, where are we? We're not doing any of those types of cycles. Over here, now we set the Z's. The rapid plane, Alt-R plane basically is a higher rapid plane that it will use while moving over to the beginning of the cycles, and then use the other rapid plane when it gets into the cycle. The drill tip angle, now as far as specifying the depth of the drilling, there's several ways. You can say in absolute, I know exactly how far I want to go in Z. You can say I want to create a chamfer of a certain diameter. It'll figure that out for you. I want to use a center drill. Here you can pick, I want to create the top part of that hole is going to be so big around, right here, the diameter, and here you select which drill you want to use, which size center drill you want to use for it. A full depth. Alright, so I want to go into where this half inch that I put here, the drill is going to go past by the tool point. Okay, and there's our drilling been done. And let's create some, let's save the file again. Always a good idea. Save the file. Alright, now let's generate some G-codes. We come over here to the generate NC code. Now there are several ways, like everything else in this system, there are usually a couple of places to attack a command, all depending on which makes the most sense to you. Here we can generate the NC code, or you can go in the machining menu and also go to the generate NC code. You select the machine from the list. If you do not see what you want in there, or you do not have your specific machine in there yet, use the Powerstation Windows desktop, select Help, select Post-Processor Setup, and when it comes up, select Where to Start. And that will guide you through loading. There's more than 100 posts already on your CD-ROM that you can load in here and use. It gives instructions on how to customize an existing one, create a new one for yourself. That's where all your instructions are. But I'll say I want to use Demo Mill, which is a pretty typical Fanuc type mill control. We'll give it a name for the NC code file, for the tape file. I'm going to give it the same name that I gave the drawing. Video lesson 1, and you just say go. Depending on the post, it might ask you some questions as it starts to run. This is a simple one, just wants to know the program number. Okay, so it generated the G codes at that point. If you want to take a quick look at them to make sure they're to your liking, you can say view code. That basically jumps this post-processor box out of your way, and then lets you look up here and look through the code. Again, the exact format of this code is completely dependent on which post-processor you have, which machine name, and how it's been set up or customized. Okay, I'm going to close that one. and close that one. Okay, next we're going to show how to do some editing on the toolpath using the job processing feature. Job processing can be accessed in the machining menu, job processing, or down here on the toolbar. This puts up a very familiar looking tree on the side that shows you the commands that you did to create this job. We're going to make one simple change just to show how it works. If I look here under operation number 10, rough on the chain cut, actually in the operation itself I made a mistake. I didn't put in the stock allowance or the tool size that I really wanted in the long run. What I wanted was an 7/8 at 875 tool, and I wanted to leave a little more. I want to leave about 50,000 stock on there. Okay. You make your changes to the operation. Same way if there was something about this cut where if you wanted to change one of the things in here, suppose you want to change the feed in this a little bit. You want to go around that outside a little quicker at 6.5 there. Basically, you make your changes to each of these. You'll notice this little box has changed. It says job needs reprocessing, has a yellow light. You just click on the little running guy here, and it reprocesses it. That took into account all my new settings I put in the operation and the new settings that I put in the chain cut. It's always a good idea, no matter what you do, to come in here, take a look at it, make sure that the processes that you see here, like these chains and drills and what have you, are what you think they are, and run the reprocess. Reprocess has a way, if you made some mistakes along the way, you've entered some funny things, reprocess kind of brings you back down to the beginning point, to the start point. It brings it back to a clean, reproducible place. So that all looks good. If you would at this point want to generate the NC code again, because just because you updated the drawing, the toolpath and everything, that doesn't automatically change the NC code. You have to say, come here and tell it to post-process it again. Next, we're going to do some sample dimensioning. Dimensioning is purely 100% optional when it comes to machining or generating NC code. It's simply for your own use if you want to include some dimensions on there for the operator, or wanted to make an actual print of your own. But we'll go over how to do it. First of all, let's get a couple of settings ready for dimensioning here. Let's select a nice color. I want to use something that's a contrast to the rest of these. I'll use that guy there. And what the heck, let's make a layer for it. Again, just makes it easier to turn things on and off. In fact, what I'm going to do is, now that I made this, I'm going to turn off the machining layer so I'm not seeing it while I'm trying to put the dimensions on it. Okay. The machining is still there. It's just not being shown because it's on a layer that is not active or not turned on. And one more thing I'm going to do, and this can be defaulted in the settings in the Windows desktop, but I'm going to put this into cursor mode. For dimensioning, the Power Snap, which is a recent addition to the system, the Power Snap comes in very handy. It makes dimensioning go a lot quicker, a lot easier. I'm also going to scroll. If you have a scroll wheel on your mouse, you can scroll in and out with it. I'm going to scroll it a little smaller so that looks nice. By the way, if you have Windows 10, you need to make a change to a setting to get the scroll mouse to work. It is documented in the main help file of Powerstation. Okay, let's do some dimensioning here. Let's start with let's take and just set up the parameters of the dimensioning, the settings in here. I like, let's see, the height is good, the default font, text height scale, precision, the pen color, Actually, everything in here looks pretty good. I like these default settings right now. Okay. Let's do some dimensioning. Let's do a simple horizontal dimension for the overall width of the part. Dimension, horizontal. Okay. This is where I say the power snap comes in handy. We have power snap turned on, which is this option right here. And we also have the points going in by the cursor mode. Especially for the dimensioning, this makes it nice and quick. See how it just jumped right to the end or the origin right there? I can say jump to the end of that and quickly just say where I want the text. Same thing if I want to do the height, drafting, dimension, vertical. Give me the end, intersect. They would all be the same thing in a case like this. Okay, let's dimension the radius of that circle there. Let's do radius. Put her on here. We got that. Okay, now we can dimension the center point of this. Would be nice. Good to know the numbers on the center of this. We'll say drafting, dimension, and the ordinate dimension would be a good way to do that one. First of all, select the base point for the ordinate dimensions. In other words, where's 0, 0? For the dimensions, we'll say right there at the origin. Okay, now it says point for the ordinate dimension. So we'll pick on that point. You can see as we move it around, it gives us either the X or the Y. Let's start with this one, with the Y, and then let's pick that point again, and put in the X. Okay. What else we got? How about the radius and then the angle dimension on here? Oh, let's finish this command first. We need to say done or escape when we're done with the command. Drafting, dimensioning, radius. Give us this one here. Okay. And let's dimension the angle. Dimension, angular. This line and this line. And put in our angular dimension. How about another horizontal one up on the top? Again, I think you can see from here, it's a pretty simple operation to add dimensions. And again, a lot of times people like it. It's good for the operators if you take and throw some dimensions on there for them to see. Good one. Let's take and dimension the horizontal. Let's take from the center of this to the center of that. Let's put this over here. Okay. I want that to not only say 1, I want it to say typical. That's a nice one to do. Let's say modify. All right, change text. Grab the text. Say 1. Typical. All right. Let's change the justification to right so it's a little bit easier to place that text. And now we just say place it about right there. We can hit the extents again to clean up the screen. Okay, that's the mill. Hopefully we'll do some more good ones from here. Thank you.